Okay, here's an example we can have a go at and try and sort the whole thing out. So first thing we do is just be aware of where we need to head to be able to use one of our formula. So here's the formula that we've got available, and the thing we're trying to solve, it's a 1 over and then a square root of something. So the square root itself isn't a problem because plenty of them have square roots in them. The thing is, the bit inside the square root either has to be the sum of squares or a difference of squares. So we have to complete the square with what we've got inside the square root. So let's just worry about the thing inside the square root for a second. So we've got 2x squared minus 7x plus 5, and we're just going to try and complete the square with that. So if we pull a 2 out the front, minus 7 over 2x plus 5 over 2, which is 2 lots of x minus, we need to halve that, so it'll be 7 over 4 squared. Got the 5 over 2, and by doing this I've now introduced an extra 49 over 16, so I need to take that away to make it all balance up again, which is 2 lots of x minus 7 over 4 squared, plus what that'd be 40 over 16 minus 49 is minus 9/16, which is 2 lots of x minus 7 over 4 squared minus 3/4 squared. Okay, so I have 2 lots of something squared minus something else squared. So the thing I'm trying to evaluate is, let's pull that 2 out the front, it has to come outside the square root, then right outside, so it'll be 1 over root 2, integral from 3 to 5, 1 over square root of x minus 7 over 4 squared minus 3/4 squared dx. Not the easiest thing in the world to read there, but there you go. So it's the square root of something squared minus something else squared. And my formula sheet that I have, the one that I can probably want to use as a formula sheet, will be this one here. Okay, because it's 1 over the square root, and the thing which is the variable is first minus the other one squared, as opposed to this one here. So we need it in that form. So z needs to be the first thing inside the square root. So we're going to make a wee substitution. So we're going to say let z equal x minus 7 over 4. And if we differentiate both sides of that, dz by dx equals 1, which implies that dx is the same as dz. So when we do our substitution, nothing really mucks up. So we get 1 over root 2 integral 3 to 5, 1 over z squared minus 3/4 squared dz. Except now I've changed the variable to z, I really should have changed the limits of integration as well. So what I'm saying is that when x equals 5, which is my first limit of integration, z equals 5 minus 7 over 4, so it's 20 over 4 minus 7 over 4. It's 13 over 4, and when x equals 3, z equals 12 minus 5/4. Okay, so I'm no longer doing a limit from 3 to 5, I'm now doing limits between here and here. So that 3 needs to be replaced with a 5 over 4, and that 5 needs to be replaced with a 13 over 4 if I've changed my limits, my variable of integration to z from x. Okay, so now it's just a matter of doing the integration, which should be pretty straightforward. So we've got 1 over root 2. Okay, oops, I've lost my square root, haven't I? Square root. There's no reason to lose the square root going from there to there. So the formula I want is this one here. It's the square root of something squared minus something else squared, which just turns into the cosh, inverse cosh of z over a. So it's the inverse cosh of z over a, which in this case is 3/4. I don't need the plus c on this because it's a definite integration, and I've got limits of integration. And now I can just stick my numbers into that. So I've got 1 over root 2 cosh inverse 3/4 divided by 13/4 divided by 3/4 of the 4's will go out. 13 over 3 minus cos inverse of 5 over 3. And then it's just a matter of chucking all that lot through a calculator, and I think the answer comes out to be 0.7406. Okay, so it's a definite integration. So the big thing at the start is to recognise that it looks like one off the sheet if I can beat up the bottom bit to be something squared minus something else squared. And then just to make sure that you get the limits of integration changed when you change your variable of integration. Or you could have left it as a z and then substitute the z back for x and done it all back to x, but it's often easier to change the limits and then just work through it.